Is the sound okay?
Sounds good, Marina.
Okay, it's loud enough, right? Because I can increase it here if needed. Okay, so welcome everyone. In this webinar, we'll be talking about taxonomic history of the diatom genus Planothidium. And I will also try to outline major gaps in our knowledge of the diversity and ecology of that genus in North America. Since it's mostly an overview of taxonomic literature, I used here a lot of images from papers published by Diatom colleagues, and also images taken by North American analysts and posted on voucher floors and also on the website Diatoms of North America. Sarah, can you proceed to the next slide, please? Next slide. Okay, so the genus Planothidium, as most of you know, includes monoraphid diatoms. Those diatoms that have one valve with raphe and another without. Until 1996, most of the freshwater monoraphids were lumped in one genus, Acnanthes. But afterwards, a series of taxonomic revisions separated various species within that genus into several genera, which are shown here on this insert. This is monoraphid panel from Diatoms of North America website. So Planothidium was one of these genera established in 1996 by Round and Bukhtiarova, and it accommodated a lot of species previously in Acnanthes. Since that time, that genus underwent a lot of changes in taxonomic concepts, but it's an important one. Many Planothidium species are common and abundant in inland waters and in marine coastal habitats. In fresh waters, they mostly inhabit alkaline and neutral pH waters, but they differ quite a lot in their affinity to nutrients, so they're very valuable environmental indicators. That's why it's important to be able to distinguish species as much as we can. Next slide, please, Sarah. So let's first talk about the characters that define that genus Planothidium. So this is an excerpt. Here you can see an excerpt from that paper by Bukhtiarova and Round published in 1996. So they introduced that genus by comparing it to Acnanthidium, another important monoraphid genus. And the character that they believe that time is the most important distinguishing Planothidium is the curvature of the frustule. If you look at the frustule in the girdle view. So on the left here, you can see Planothidium and girdle view. On the right is Acnanthidium. In reality, that difference in the curvature is not that huge, I would say. Planothidium is still curved, but that's what Round and Bukhtiarova were thinking at that time. So that's why they invented that name, Planothidium, to reflect that idea that it's more flat. They didn't say anything at that time about that big difference between these two genera, which is their growth habit, because Planothidium and actually the majority of Acnanthidiaceae, they have prostrate-like growth habit, while Acnanthidium is the only genus which is able to produce stalks. So next slide, please. So here is the original description of Planothidium, and I underline by red lines here the most salient features of that genus. So thick bi-multi-serried striae. You can observe that in SEM only. So if you want, you can use your cursor to show these multiple rows of areoles that form the striae in Planothidium. Then that's what they say also. Striae continues in the delicatula type of species or interrupted centrally on the raphe valve, interrupted on one side in the rapheless valve. And here marked by a hoof-marked depression. We also use another term for that depression, sinus. That's just another name for the same thing. So depression of sinus is found in Lanceolata, Planothidium lanceolatum type of species. And in some taxa, that hoof mark is actually, that depression is covered by a capped structure, which is called either hood or cavum, or cavum, whatever, how you want to pronounce. It looks like a little cave. Sarah, you can show that also, like with your cursor, if you can.
Sarah, could you just check that people are muted?
Yeah, somebody is talking. I can see, I can hear the sound. Another feature is the raphe, which has terminal raphe fissures. It says here, raphe often centrally expanded and turned to the side at apices. This is an important feature. Here, we now call this terminal ends of the raphe terminal fissures. They are shallow grooves on the external surface of the valve. And in Planothidium, they usually go, they're long and curved, go all the way to the mantle. Yeah, here, right, that's good. Okay, we can proceed to the next slide. So what happened after that genus was established in 1996? 73 species were subsequently transferred to Planothidium, mostly from Acnanthus, but also from other genera. Then 6, actually maybe even more, were transferred afterwards to another genera. So they first transferred to Planothidium and then somewhere else. And then 54 new Planothidium species were described since 1996 up to now. Some were described twice and some were described not validly. Okay, the next slide, please. Okay, here I'm showing you some of these groups which were established as new species, new genera, and the species were moved from Planothidium to these 3 new genera. The first one is Taxa, which has even more flat valves than Planothidium. It has biseriate striae. If you remember that original description of the genus Planothidium, it says biseriate of multiseriate striae. So Taxa has biseriate striae. And another important thing, it doesn't have terminal raphe fissure. If you look at the raphe, it's straight all the way around. So there is no shallow groove going to the mantle on the both sides of the valve. Then Gliwice, another genus described in 2013. This one is kind of special. It includes Acnanthus calcar and related taxa. These guys, they have cavum on both valves, rapheless and raphe valve. The striae are uniseriate, so it definitely doesn't fit into Planothidium. It also has stauros on both valves. And then we have Skabichevsky, described 5 years ago by Kulikovsky and co-authors. That one has cavum on rapheless valve as Planothidium, but the striae on rapheless valve are biseriate and they're uniseriate on the raphe valve. Okay, Sarah, can you proceed to the next slide, please? So it would be all nice, but the problem is, so far, we don't have a consensus, no agreement on the boundaries between these new genera and within actually most of the genera within the family Acnanthidiaceae where Planothidium belongs to. The problem is that most genera are not defined by molecular or morphological synapomorphism, shared derived characters that are the only and most important way of establishing monophyly. Perhaps Gliwice has some of those, like stauros and that cavum on raphe valve, on both valves actually. Also, Acnanthidium minoticium group could be a good genus because it has, they do have that synapomorphy stalks, and this is the unique within the order Cacaneidalis, where the family Acnanthidiaceae belongs to. Instead of monophyly, most genera in that family, they are defined by combinations of rather few morphological characters, like presence and length of terminal raphe fissures, number of rows of areola per striae on each valve could be different, could be the same, presence of cavum or depression or absence of either of those. This is not very good situation, as I said. That's not the very good way of establishing genera, but that's what's happening right now. On top of that, many species share characters of several established genera, and therefore they are assigned by different authors to different genera. Okay, next slide, please. So here is an example of this pair of species. One is in Planothidium, Planothidium distinctum, found mostly in cold waters in Europe, also in Alaska. On the right, we have Taxa stewarti, which is pretty common especially in the eastern part of the United States. If you look at the ultrastructure, it's kind of similar. And also in Freshwater flora, Langeberta would put them side by side because they are kind of similar to each other. They have biseriate stripe, both of them, and you don't see these long terminal reefy fissures. Taxa stewarti, the reef really totally doesn't have any terminal reefy fissures, so it's comfortably sitting in Taxa. If you look at Planothidium distinctum, it's a little bit longer, but it's difficult to tell if there is any shallow groove past the helicta glossa. We don't know, but they are in different genera, right? Also, Planothidium distinctum has 3 areolar on mantle perstria, which is also not a character of Planothidium. Okay, next slide, please. Here are 2 more examples of taxa which are sharing characters of Planothidium and Taxa. Taxa strelnikova that we described several years ago has biseriate stripe, no terminal reefy fissures as Taxa is supposed to be, but it has depression, the same type of like Planothidium lanceolatum has. Then Taxa balsi that I described 8 years ago doesn't have terminal reefy fissures like Taxa, but it has multi-seriate striae as Planothidium. So Kulikovsky and his collaborators who are pursuing this narrow genus concept, and they're trying to create new genera for each combination of characters, they're arguing, you know, that they belong somewhere else, and they actually transferred Taxa balsi back to Planothidium. Okay, next slide, please. This is another example of taxon like that. It's in Dona website, it's in Planothidium, it's Planothidium ursacensis, how Langeberta would put it. And it has cavum. And until recently, nobody had SEM photographs of that species. Chudaev and collaborators got the first SEM photos. And they saw, if you look at them, this guy, it has uniseriate stripe. They transfer it to Taxa because they don't, that species doesn't have terminal reefy fissures. But again, Taxa is supposed to have biseriate stripe. So following their own logic, it should be somewhere else, maybe like another genus. But we have these differences of opinions of whether it makes sense to create this new genera of each new combination of a few characters, or maybe not. Maybe we should accumulate more characters, maybe molecular characters, before we proceed with further revisions. Next slide, please. But regardless of all this instability and these very fuzzy borders between genera, there is this core group of freshwater Planothidiums. And within that core group, there are several smaller groups that I tried to define here. And it's important for the purposes of using them as environmental indicators. It's kind of important to figure out boundaries between these species, to describe them really well. So the groups that I tried to break down this core group into, they're pretty much artificial. They don't necessarily mean the monophyletic groups, but just for the convenience, I divided them into species with asymmetrical central area and reefless valve and symmetrical areas. So on the left, we have those with either depression or the cavum, lanceolatum with depression, frequentissimum, rostratum, and also the larger ones with cavum. On the right, you have delicatulum group and also the tiny things. Okay, the next slide, please. Sarah, okay. So let's start with lanceolatum group. That's the first one, with depression. There are two major studies here which were like really important for figuring out diversity of that group. First one was published by Bart van der Wijler, who actually studied the type material of Lanceolatum. So his images are on the right. So we know how the type looks like. That allows us to separate other things into different species. Then the next important paper was published by Regina Yan and collaborators who cultured quite a lot of strains from different regions, from Russia, Germany, Korea, South Korea, and Mexico. And they sequenced two genes, RBCL and SSU, and they figured out that what we usually call Lanceolatum falls into two large clades, monophyletic groups. The one on the right corresponds to the morphology of the type of Planothidium lanceolatum. One on the left, they invented a new name, established new name for that. They called it Planothidium cryptolanceolatum. Crypta tells you something. It's really difficult to tell morphologically that thing apart from the type of lanceolatum. So they claim that the difference is in the shape of the depression. I also see a difference in the central area of the raphe valve. So if you look at lanceolatum type, the central area of the raphe valve has bigger central area, right? In cryptolanceolatum, central area is smaller. But to be honest, if you're counting these guys and you're like encountering them in your count, I'm pretty sure it would be very difficult to put your specimens in one or another one. So what do we have here? I'm not entirely sure. We can have even larger diversity that was captured by this study. Two strains from the United States were included in that Regina Yan study. One is from Pennsylvania, from creek behind my house. That strain was nested within cryptolanceolatum clade. Another strain that Lauren Bowles actually collected from Montana appears to be sister to the whole clade of cryptolanceolatum. So we may have some bigger diversity here. Okay, the next slide. So in the same paper, Regina Yan established another species, Planothidium Taxa from Korea. That strain was isolated from Korea. So the shape is quite different from Lanceolata, but it reminds a little bit of Planothidium dubium on the right, which is pretty common species, and it often reported from North America and Europe. The shape is quite different, but to be completely sure what you're dealing with, it would be nice to have an SCM, because Taxa has 2 to 3 rows of areola per striae, and dubium has 4 rows, which become 3 rows of areola towards this axial area. The problem is the lectotype. If you look at the lectotype of dubium from Belgium, looks a little bit different from our specimen. So I'm not entirely convinced that what we have here is actually the same species. Okay, the next slide, please. Okay, this is another important story here. Planothidium hynaldi is a species which was also recently completely overhauled by Wetzel and his collaborators, who published the study of the type material of hynaldi from South America. The problem here is that if you look at images of Planothidium amphibium in the upper right corner of that slide, that's what we used to call hynaldi in the past. And this is not just because we are so silly, it's because that's how hynaldi was represented in all floras, in Patrick and Reimer and Wasserflor, and also on Donna page. So before Wetzel, Carlos actually looked at the type material of real hynaldi. That's what we thought of hynaldi. So he said, no, you know what, the real hynaldi is only found in South America, and it's different from what we have in Northern Hemisphere, in the colder waters of Northern Hemisphere. That new species, he called it amphibium, and that's why I had to change that page. So looking at the type material is very important. So it allowed Carlos and his collaborators to distinguish other species, like for example, Planothidium capitatum, which is actually a species from Antarctic region, but it was also lumped before into high mildew. So again, we only have amphibium here in North America. Okay, next slide, please. So now we are moving to frequentissima group, those guys with column, with the little cave. Fortunately, I should say, if you're counting diatoms, you probably know that frequentissimum sensulata comes in all types of sizes and shapes. It's kind of a lot of diversity here. Fortunately, we know how the type of Planothidium frequentissimum looks like. If you look, here, these images here on the upper left corner, those images of the type from 1-236 published in Süßwasser Flora. The problem is when you're counting, you don't know like how different your specimens should be when it's enough to move them, or if it's already good to move them out of that species. So the boundaries are not well defined. And actually in Süßwasser Flora, many species which are being separated right now, they were all lumped together under that name of Planothidium frequentissimum. So again, that paper by Regina Jan and her co-authors, published in 2017, was very important. Again, they had several strains sequenced from different regions. And similarly to that story with Lanceolatum, they figured out there are two big groups, two clades here. So one on the left, the valves are kind of similar to the type of Planothidium frequentissimum. Can you go back to the previous slide? And those on the right, it's another clade. So they established a new name for that. Initially, it was called Planothidium caputeum from Germany, but then another strain from New Zealand happened to be nested. It was sequenced also, and it happened to be nested within that clade, and it was described before as Planothidium victory. So now these guys, they have that name, Planothidium victory. And what Regina Jan and co-authors said about morphological differences between these guys, they said the hood, the column is different. They said that in frequentissimum, the column is round, while in Victory caputeum, it's V-shaped. And I know what you think about that. They're before your eyes from that paper. And I honestly, I wouldn't be able to tell much difference between these two types of column. And I see more difference in the valve shape. Can you move to the next slide? But this is what we have in the United States. So those are just some panels of images from different voucher floras. And honestly, I wouldn't be able to separate those, tell which one is which. And the thing is, the single strain which was sequenced from United States and was included in that Regina Jan study is actually sister to Victory clade. But in my opinion, the valve outlines in most of these specimens are closer to frequentissimum. So far, I'm just leaving everything under frequentissimum sensulata page until we have a nice study, sequence lots of strains across the North America and figure out what type of diversity we have here. We can move to the next slide. Okay, those are two other species from the same group with column frequentissimum, which were really recently described, one from Korea, one from Europe. I just putting them here in case we can catch them. The shapes are more or less different from what we've seen in the previous group, so we should be able to identify them right now. Okay, next slide. This is a pair of taxa which are similar to frequentissimum in many respects, but they have this very wide axial rhombic lanceolate axial area on reefless valve. The species on the right, Planothidium abbreviatum, is common, especially in the eastern part of the United States. I cannot say like really common, but you encounter it from time to time. And the one on the left is Curtis striatum, recently described from France. You can tell the difference. It's much smaller, the striae are shorter and sparser, and it has like pretty nice like normal column, while Abbreviatum has a really shallow column. I just put that Curtis striatum just in case we may have missed it. Maybe it was lumped in Frequentissimum before, who knows. Okay, the next slide, please. This is an important pair of species. So until recently, again, they were all, both of them were lumped under the name of Planothidium biparomum. It was done in our donor labs site. And when I made that page, I followed the concept in Patrick and Reimer and also in Suswasser Flora. That's how we were thinking they are the same. Again, Carlos and his group, they carefully looked at the type material of biparomum, which is Savannah River in Georgia. And this is that capitate form on the right. And they figured out that most of the specimens we're actually encountering in North America, all over North America and Europe and all over the world, they look like specimens on the left. And it's a different species from the real biparomum, which is on the right. They established that new species, they called it Planothidium incuriatum. So I had to split our page into two. That whole confusion actually started from Hohenfellermann, from the original description of biparomum, because they listed one of the localities they listed was Lavaz River in Canada, which actually had incuriatum in that sample, and that's why Lange-Berthelot looked at that sample and decided it's biparomum. Okay, we can move to the next slide. Okay, this is another pair of species. I keep showing this pair just to contrast them. They are similar. These two species are similar in many respects. One on the right was recently described last year, described by Rosalina Stancheva from California, Planothidium shitei. And one on the left, again, described the same year, last year, from Germany. So what we have here, they also kind of belong to Frequentissimum group. They're a little bit bigger than Frequentissimum, and the column has this flared sides. And they also have like really interesting mantle areolas. So you can show them on this. See that group of areola against the striae. That's kind of unique feature for both of these species. But they're different. Fortunately, the shitei is bigger, and Hinsanum is smaller, and it has pointier ends. So in case we have Hinsanum also, in addition to that shitei from California, we should be able to distinguish it. Next slide, please. Okay, now we are moving to Stratum group. This one is difficult because these species are rather small. And there was lots of confusion here. We should go back to the previous slide. They were pretty much, no, the next one, next. Here, yeah, just stay here. Many species which are teased apart from the group now, mostly by Carlos Wetzel and his collaborators, they were all lumped into that Planothidium rostratum group under one name. So here, the problem is there were two species described initially. One, Achnanthes rostrata, described by Ostrup in 1902, and another, Achnanthes lanceolata variety rostrata, described by Hustedt 1911 from Germany. They are more or less similar in outline. The difference is very subtle. Nobody knew about the difference until, again, Carlos Wetzel actually looked at the types. And basically, if you look at the column, at the shape of the column, you can see that difference even in the light microscope photos. The column in rostratum, which is Planothidium rostratum right now, is more narrow, while it's wider in the species on the right, which actually has another name right now, Planothidium rostrata halarcticum. Lange Berthelot and Bach established that new species. So that rostratum, Planothidium rostratum on the left, described initially from Thailand, is a tropical species, more or less tropical, while rostrata halarcticum is common in temperate climates. It's difficult to tell them apart. It would be nice to have a SEM study. Under SEM, you can see they have different number of rows of areolatar striae, more on rostratum, fewer on rostrata halarcticum. Let's move to the next slide. The thing is, Wetzel in his paper actually says that there is good probability that we can have both of them in North America. And I'm afraid we can have even higher diversity. It's maybe not that simple. If you look at these panels of these valves here, especially that one in the left lower corner, it could be even something else. We really need a good SEM study here to figure out what we're dealing with here. So right now, I'm just making, the page is not open, but I'm just making a rostratum sensillata page for these things, keeping that open for the next study. Next slide. There are more species that Carlos and his group actually teased apart from rostratum. So those are two on the right, 2G from Japan and Gallicum from France. And I think we have that Gallicum. So these are specimens on the left. They're from southeastern United States. And I think they look pretty much like Gallicum. So that's another thing. The next slide. This is that Potapova thing they described it. They call it after me because it was my page that mixed actually that species into rostratum. So now I had to move it to another page. This one is pretty easy to recognize because it has like really wide axial area and like really thin necks. Those two on the left have not been reported from North America yet. One, Alexeyeva, was described from Russia, but you can go back. It was also reported from Belgium, Uruguay, and who knows from where else. And Brazilians, I just put them here because I think we may have them here, just in case somebody finds them here. Okay, next slide, please. Okay, next group, larger cells with cavum. We basically have two species here, maybe more, I don't know, but those are more or less common. Apiculatum, mostly in eastern United States, and Lanceolatoides, and kind of common in Pacific Northwest and oligotrophic environments. The difference is mostly, like, most noticeable difference, morphological difference, is in the shape of the central area of race bulk. You can see it's more or less oval in apiculatum and bow type shaped in Lanceolatoides. Okay, next slide. Okay, Delicatulum group. So we move to the next group without asymmetrical central area. All areas are symmetrical here. Delicatulum. Again, most of the confusion comes from the fact that many species were lumped together under that name, Acantha's delicatula, in Susvasser flora. The paper that clarified quite a lot about this group was published by Bart van de Wijsberg and co-authors in 2018. They actually looked at the type. They found the type, Kutzing's type of Planothidium delicatulum. Yeah, that's what Sarah is showing you. It's how it looks like. These pointy things, those are real delicatulum. The trouble is that in Susvasser flora, when Langebertel was putting it together, he thought that the type material was lost. So he established a neotype. The specimens in their right lower corner, they basically are those that he, like Langebertel, showed as the neotype of delicatulum. And Bart actually found that those are it's something else. It's another genus, another species, and it's marine species, which was described as Planothidium galaicum from Spain, and it's epiphytic on brown algae. So that neotype in Süßwasser flora is really misleading. So it's not delicatio, it's something else. Then there is this species in the upper right corner, Schwabe, which is more robust. It has the structure of delicatulum, but it's bigger one with thicker striae. But it's a different thing. And when it was actually recognized and published in the Diatoms of Andes, iconographia, people started encountering it in other places, like in Europe, for example. So we also may have it here. So the specimens in the center of that slide, they're from northeastern United States. So the upper row shows those which fit perfectly into the type of Planothidium delicatulum. Those and the lower row, I'm not sure, could be something else. We need to study those. Next slide, please. So these species here, they belong to the delicatulum group because they have similar ultrastructure, also long terminal rapid fissures. But the thing about the ultrastructure, if you look at the surface of the rafless valve, it's undulating. That's how it is in the delicatulum group and also in this in this species. There was a long-standing confusion about the name Planothidium engelbrechtii. For some long time, people believed it's marine species. Until recently, not recently, 2009, Compare and Van de Wieswerp studied its type material, which is actually from freshwater locality in South Africa. And they basically showed how the real thing looks like. Another species which is very similar, it's one on the left, Planothidium lacustre from Spain. I'm not even sure those are two different species. They're very, very similar. The species in the center, Planothidium haukianum, that's a very confusing one. It was described from very alkaline river from Yugoslavia by Husted. Has very parallel stria on both valves. But the name was misapplied, historically was misapplied to delicatulum and other delicatulum-looking taxa. So it also was applied in kind of delicatulum-looking specimens, but without these pinched ends. But we should be careful about this one. It's apparently a very rare one. I'm not even sure we have that one here. The type, those are images of type, but the type was never studied with NCM, so that's another problem here. Next slide, please. Okay, now we reached the last group, which I call tiny. It's totally artificial, I admit it. The only thing that unites them is tiny size and the absence of these asymmetrical central areas with some structures. So here in this slide, I have two species which look very similar to me. They definitely are phylogenetically probably close to delicatulum, because if you look at that surface of that rafless valve, especially that in the pumilum, because it's under angle, you can see how undulated the surface is. It's exactly the same type of ultrastructure we have in delicatulum, and the stria are on the raised portions of the undulation of the valve surface. And the stria, as in delicatulum, they're composed of 5 to 6 rows of areola. So pumilum from Poland, neglectum from Chile, nobody found them in North America, but they're tiny things, we may be overlooking them. I'm not sure they're different. The neglectum is slightly bigger, but I don't know. Okay, the next slide, please. Okay, so this is another pair of species, a little bit more rhombic outline. Rambiculum described from Germany, and Planothidium granum. This is commonly reported from North America. Granum was described by Holland Hillerman from Lavaz River in Canada. The problem with granum, which is commonly reported, is that There was a type slide in our collection, and Lange Berthelot long time ago studied that type slide and published these images in their upper right corner of this slide, published them in Süßwasser Flora. They look like probably two different things here, but subsequently that slide was lost and the type material was never found. So what we have right now is just our interpretation of that species. For example, Eduardo Morales published a paper in 2000. We actually looked at some populations in Florida which kind of look like granum. So that's the best we have right now. So if you following his concept, they have this delicatulum-like structure, again, this undulating valve surface on raceless valve. What do we have here? That was in the previous slide, these California vulture flora specimens. I have difficulty placing them anywhere. They may be granum, they may be some, like the smaller ones could be something else. Again, we need a thorough study of these small guys here. Okay, the next slide. Oh, Rosalina did SEM, good. Of what? Okay, so another pair of tiny things, one from Korea, Suncho Manenza, Regina Yan and Zimmerman actually described that one, and Minotissimum. This is again, this is not type material, which type is from Spitsbergen, from Svalbard. This is again Eduardo's interpretation, although this is pretty special. There is quite a lot of morphology here. See these two distant striae on one side of raceless valve. So it's pretty confident that what it is. So Minotissimum is commonly reported from a temperate climatic zone. We probably can also have that Korean taxon here. I'm not sure. What's common about for those two, if you look at the striae around the central area of the raceal valve, they're triangular. They're pointy here, but obviously they're quite different. Okay, now move to the next slide. I think this is probably my last one, right, for this group. So Dowie and Lemermani, they're a little bit similar to each other and might be sometimes difficult to tell apart. But those are two different taxa with different ecologies. Dowie is pretty much freshwater taxon, and unlike many Planothidiums, it actually likes low nutrient environments, while Lemermani is often reported from brackish water localities. So we have images of holotypes on the light microscope images. And again, Eduardo just interpreted some populations from North America and did some SEM studies. But in most cases, people, as I understand, don't have much difficulty telling them apart. Of course, if we accept that what we have as Dowie here is exactly as the type from Denmark. It's difficult to tell until somebody actually studies that type of SEM. Okay, can we move to the next slide? So this is actually my conclusions for this presentation. So basically what I wanted to say, investigations of type materials led to big changes in taxonomic concepts of several old and important taxa. And has been considerable progress in unraveling species diversity within Planothidium, and we witnessed rapid and profound taxonomic changes. But North American populations are relatively poorly studied compared to European, for example. And we have much to learn about ecology and indicative properties of recently recognized species, and the species whose taxonomic concepts were narrowed down recently. That's all from me, so I would be happy to answer questions, comments.
Thanks, Marina. So a few times, Marina mentioned diatom specimens from the Northeast, Southeast, Pacific Northwest. You can access some of those pictures on the link I put on in the chat of those voucher flora. And I see here that Rosalina, I think she meant that she did SEM study of California specimens that, yeah, that look like small Engelbrechtii.
Yeah, that's what I mean. It's very important to accumulate a lot of morphological data, and molecular data would be great.
Xavier Benito says, thanks, Marina, great presentation.
Thank you.
Rosalina asking, do you think ecologically it makes sense to split Lanceolatum and Frequentissimum following Yan et al. 2017?
Definitely makes sense to split them. The problem is, what do you do when you encounter these specimens in the count and in your slide, and you're not sure? There's so little morphological difference. It's just difficult to tell them apart. They probably are different ecologically. We don't know because we were not able to accumulate that data yet.
Okay, Clint Davis asks, are the California vouchers available online?
This is Sarah. I can address that question. We have not yet compiled the final California voucher, so they're not yet ready, but since you asked, that will prod us to get them ready and post them. So thank you for your interest. Clint, I'll let you know when we put them up.
Oh,
yeah.
I see.
You can see it, yeah.
The list of citations. I was thinking about actually doing that. I don't know. I can maybe like it would take several slides on the presentation. It would make more sense to put them together, maybe like in a Word file, which could be posted somewhere together with this presentation. I don't know.
Sure, Marina, if you put together the citations, we could just put them at the bottom of where this talk is announced on DONA, and where people will later be able to access the recording so that they could just see the list of taxa.
Yeah, I can do that, definitely.
I mean, of citations, sorry.
Rosalina said, it seems we need to culture and sequence Planothidium from the US.
Absolutely.
Yeah. Marina, can you talk about, from your experience, what are the ranges of ecological preferences of Planothidium species?
So what I think, like, if you take the whole genus as the whole, it's common in brackish waters, in marine coastal habitats, where the species are probably different from freshwater. In freshwater, it's more or less on the medium to high conductivity side, pretty well buffered waters. I don't think many species of Planitodium like acidic environments. Maybe a few are in more diluted waters. I suspect that Potapova is on that side, but this is just based on my like anecdotal, you know. There is no data because nobody analyzed them separately yet. But what's interesting, I think, about these Planothidiums, they should be good indicators of nutrients, because you have some species like this Lanceolatoides, for example, Distinctum, Finaldi, they're on oligotrophic side. Frequentissimum, Lanceolatum, they like eutrophic environments. So yeah, there's lots of variability here.
There's also a link in the chat to a nice PDF of Planothidium workshops from Bart van de Bever's Dutch-speaking diatomist group.
Mm-hmm.
It's an excellent resource.
Yep. Former has a circular shape to the interior of the column. Yeah,
So Marina, let me just read it so it gets on the recording.
Mm-hmm.
Sorry. One thing I noticed in the plates of Planothidium rostratum and Rostrata holarcticumis, that the former had a circular shape to the interior of the cavum, whereas the latter had a oval or egg shape. So something to think about when diagnosing the two.
Right. Yeah, that's the thing. They definitely have different cavum shape. I don't know like how easy that would be. They would be to separate when you find them in the counts, because usually what happens, you have these papers written by systematists who say this is one and this is another, and you count it and you find something in the middle. You know, like when that column would be not as narrow as in this one, not as wide as in that one.
Thanks to everyone who put in their name and location. Very cool to see everyone, where everyone is coming from. Maryland, Maine, Kingston, Canada, California, Poland, Indiana, Texas, Minnesota, Milwaukee, Argentina.
Wow.
So many places. Serbia, Philadelphia, Ireland, Florida, Colorado, Miami, Idaho, Michigan. Very cool.
Very cool. Nice. I hope everyone is in good shape and good spirits despite of what's happening around us.
Mm-hmm.
Able to think about Planothidium. That's great.
Yeah.
Yeah, thank you everyone for joining us today. I'm really glad that we could all join here, even though we can't be where we might like to be. And I hope that everyone stays well and stays safe. And let's continue to connect in the ways that we can. I will take this recording and it will be posted on Diatoms of North America in just a couple days. So you can go back and review the presentation and have the images and the questions that people ask. And I hope that you will join us again for our next webinar in 2 weeks, when Nick Schulte is going to be giving a presentation on using diatom DNA in environmental assessments, techniques and timeline to operation. So thanks everyone. And if we didn't get a chance to talk, please contact us, any one of us, by email, and let's keep our diatom world together.
Thank you, Sarah.
Bye.
Thank you. Bye, everybody.
Bye.
Bye, everyone. Thank you.